This is Hacker Public Radio, episode 3619 for Thursday, the 16th of June 2022. Today's show is entitled Linux Inlaws Sai, Kubernetes and Friends and Sarah. It is hosted by Monochromic and is about 68 minutes long. It carries an explicit flag. The summary is: the fun continues with a discussion of container orchestration, frameworks, death of containers, and
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs.
This is Linux Inlaws, season something, episode 59, if Martin reminds me correctly. Martin, how are things?
Yeah, not too bad. Well,
excellent.
It could be a lot worse if you're living in a certain part of the world, but yeah, so all good over here. How are you?
Well, surviving, I suppose.
Surviving? Are all limbs attached still?
All limbs attached, yes. The last body count showed that I'm somewhat
body count?
Yes.
How many bodies do you have?
Body count.
Is this something in your cellar that we shouldn't ask about?
No, Martin, you shouldn't. Anyway,
Okay.
So how's the kingdom doing these days?
The kingdom, the Dutch kingdom, yes.
No. Well, not but that used to be called the United Kingdom. Anyway.
That's actually not a good name, is it? Because we have a queen, so it should be the United Queendom. But there we go. I suppose they didn't bother changing the name.
Yeah, United is probably kind of in what's the word I'm looking for? Exaggeration these days.
I don't know.
It's called Little Britain, if not completely mistaken.
We still
right?
have some
in the show notes.
Some Welsh people and some Scottish people attached to the UK.
Yes.
So, talking about countries and stuff. How is your? How smelly are you?
How smelly am I?
Well, surely you've stopped taking showers and using gas and stuff like that.
Martin, of course, is referring to the Second World War, but I'm not that old, Martin.
No.
I'm okay. I'm okay.
No, I'm referring to your the need to use less gas. This when I was over in Holland, they had adverts saying, take shorter showers and
because of the Russian.
Yes,
I see.
Yes.
No, I'm still living I'm still living with what's what I'm looking for? High life, exactly. So somebody has to support Putin, no?
Well, that's debatable. I don't know. Does anybody actually support him? That's a good question. Yeah.
Well, that's a very valid question indeed. No. As a matter of fact, I haven't seen these ads that people. I mean, is it really rolling in the Netherlands? As in, you should cut down on energy consumption. Okay. No, at least not here in Germany.
Okay.
But then this whole thing is quite cool anyway, because on the one side we're paying Russia billions, I think, if on a given day, maybe in a week, for gas and to some extent also oil. But at the same time, apparently, we are funding the Ukrainians with an elaborate scheme of weapon exchanges.
But probably not quite to the same monetary amount. But
I don't know how much the federal government has committed in terms of billions being poured into this, but apparently the deal is that the Ukrainians get Russian heavy artillery from some other countries, and in turn Germany gives these other countries modern stuff as a modern kit.
Okay.
Which is handy.
Trading deal. Yeah, okay.
Exactly, because
trading your tank deal.
Exactly, because the existing kit is of course of Russian origin.
Right.
This is the irony of things.
Oh well.
Which is clever because you see the Russians in that case do not know who they are facing. Because if it's all Russian kit, what the hell?
Yeah. True.
But
they still have plenty of spares as well. That's quite handy.
Yes, but of course this is not the current affairs podcast.
No, it is not. No.
Funny enough, no. This is actually the what's the word? What's the name I'm looking for? Linux Inlaws podcast.
That's the one. Yes.
One of the leading.
I know it's been a while.
Yes, podcast.
It's the fastest growing one, surely.
Exactly. Hacker Public Radio stats or not. Ken, if you're listening, thank you for hosting.
Oh, they're doing stats now?
No, they're not.
Oh, okay. I was just hopeful for a moment. But yeah,
as we all know, downloads and website imprints are voodoo anyway, so no sweat.
Indeed. So today's episode.
Exactly, today's episode is on one of Martin's favorite hipster subjects, namely containers and also orchestration.
Hang on, I thought we did
frameworks. Exactly. We actually, as a matter of fact, we did operating system level virtualization, of which containers are an important part.
Yes.
Speaking of which, Martin, you want to give a short recap of the previous episode?
Well, we talked about operating system virtualization.
Excellent, Martin.
That's a very short recap.
Yes. Of course, that's a very bold teaser to download the previous episode. I think it's 52 or something. Details maybe in the show notes.
It's 58, no? It's the previous one.
50. Yeah, I don't know. I can't remember. It's one of the previous episodes anyway. Yeah, exactly.
Okay. Not true.
And the long and short of it is essentially that we kind of gave an overview of the different operating system level virtualization approaches, of which containers are probably the most recent addition to that zoo, and probably also the most en vogue ones. Because everybody's using containers. You actually see this if you take a look at...
Well, you say everybody, but you mean like hipster developers, right?
No, you see, which is funny, because if you take a look at any viable, any popular project on GitHub, whether it's a database, whether it's a piece of middleware software, or something else that requires a little bit of installation effort, chances are that as part of the quick start, you have a Docker file that you can use to set up your container.
Yeah.
So you don't have to install the stuff manually
in
a virtual machine or something like this. You just download the Docker file, then you invoke it, you build the image if it's not kind of regularly available on Docker on the Docker hub, and then you have a running container, and then you can start to play around with. Redis, Mongo, Couchbase, and other NoSQL databases are probably the most prominent examples in this space. Not too sure if you followed Redis Conf, Martin.
No. Does it still exist?
Yes, it does.
Okay.
And Redis released something called Redis Stack.
Yes,
which is of course available.
Marketing blurb from some some woman,
and that is of course available as a container.
Okay, a very small stack. Okay, fair enough. Yep.
However, blatant teaser. As I'm still working for Redis.
You mean a marketing plug, not a tease.
And people just use a favorite search engine. Redis Stack essentially is a combination of open source Redis as you find it on GitHub, plus all the modules that come with Redis. But enough of marketing. But enough of the marketing thing. Today's episode is not just about containers, but rather about orchestration approaches on top of containers.
Yes.
Because as we all know, containers being the hipster operating system level virtualization approach of today, of rather recent times, running containers in themselves is not enough, because essentially the idea is to have, and that goes hand in hand with this whole microservices thing, because the idea is to have a container per microservice. So the idea is to package any supporting infrastructure that you need, like middleware databases, queues, and other components that make up your ordinary or normal app stack as containers, leading to probably quite a few containers over time, depending on how you structure or restructure your existing application stack. So in contrast to previous times where you simply had a code monolith, like your few gigabytes of compressed Java virtual machine bytecode executable, which you then would simply
days, yeah.
exactly, which you would simply put on a computer and then pray that it would work. These days, you have about 100 million little containers all doing their own thing, but they of course need monitoring, deployment. You maybe want to scale these deployments up and down depending on your workload, on your traffic on these containers, all the rest of it. So the days where you would simply set up a container manually and shove it into VM or into a cloud or on bare metal are simply gone, especially if you're talking about real production environments that carry real workloads.
Indeed. Okay, so this is where you're going to have some examples of orchestration frameworks.
Well, Kubernetes comes to mind, no? It's one of these hipster things that have been pushed severely by our favorite search engine company called Google.
Well, it used to, yes. But, most of these people now work for VMware, by the way.
I think that's a bold exaggeration, Martin, because I think Google is still 100,000 employees strong, maybe 60 or something.
Well, that's not the Google.
They keep hiring
the Kubernetes people. Yeah, okay.
Sorry, I thought maybe you meant Google in general. Okay. Well, Kubernetes.
I don't know actually. How is Google doing? They seem to be a bit quiet these days.
Well, the last quarter apparently wasn't that great, but this is just your ordinary dip, I reckon. In the
downturn of the cloud, everybody's going back to on-premise.
Yeah. If you say so, Martin. Well,
actually, a lot of people haven't left yet.
But you see, Kubernetes, as many other frameworks, is open source, so I'm not too sure where the contributors come from. GitHub probably will be able to tell you, but anybody can contribute to Git.
I was talking about the original founders of Kubernetes, like and Craig McLuckie.
And they went to VMware. Why?
They did, because we are one of the biggest contributors to Kubernetes, obviously. Anyway,
of course, what's for VMware these days?
It's but anyway, we're not just talking about VMware and Redis. We're talking about container orchestration.
Indeed, no, exactly.
Before we move on to Kubernetes, what other orchestration options are there for people?
Well, there's a couple of obsolete ones.
Okay.
Docker Swarm comes to mind. Sorry, Docker Swarm was Docker. I mean, I came across one company that actually uses still use Docker Swarm these days. But there have been the Docker shops for at least 6-7 years, maybe 8, and invested heavily into the technology. But all the other companies that I know that used to use Swarm, they essentially migrated to Kubernetes. I mean, the approaches are pretty much the same.
Cool.
You're looking at frameworks that can set up a cluster, can scale deployments up and down, can manage containers.
Well, it's also the service access, all that kind of stuff. And
exactly, and the notions on top.
Yeah.
like configuration aspects, things comparable to kind of classical configuration management databases, CMDBs. Security, aspects like authentication,
users,
namespaces, exactly.
Yeah.
So the things that you find in Swarm, that you find in Mesos, that you find in Data Center OS, but also in Kubernetes, goes without saying. But it's probably fair to say that Kubernetes is the most popular one at the moment, which is interesting because Kubernetes strives heavily to standardize things. You can see this actually if you take a look at what's happening under the hood, because Kubernetes, for example, as probably quite a few listeners know who have looked at that technology, is container technology agnostic, meaning you can use any OCI compliant as an open container initiative, OCI compliant container framework. The default one is, of course, Docker.
Well, it was, but
I thought it was
I see a lot of people moving over to Containerd now.
Sorry, if you my mistake. If you use any quick start thing like Minikube, but we're going to go into that in a minute,
Minikube.
Or Cube ADM or whatever, as in Kubernetes.
Who runs Minikube in production? Hang on a minute, what's going on here?
Sorry, Martin.
I must have missed something.
Quick start and easy entries to Kubernetes. They would normally use Docker as the go-to default container.
Okay. So I was talking about production deployments. Yeah.
But still, I don't know that many people that run very different technologies. Cryo is becoming more and more the norm in contrast to Docker. But Cryo essentially is a stripped down version, if I'm not completely mistaken, of a previous Docker version. As in just the stuff that you need in order to
at all in anybody really
to create containers, to manage containers essentially under the hood. Well, it's. Most of the time,
as a runtime is most people seem. What I've seen is moving to Containerd now, but anyway, it's a detail. We're talking about orchestration at the moment. Yep.
Yeah. Well, Containerd is OCI compliant too. You can use any OCI compliant container runtime. Probably Cryo stands for container runtime something. It wouldn't surprise me.
That would be sensible. Yeah. So where were we anyway?
You were just going to explain what Kubernetes is and why the other frameworks have fallen into oblivion.
Yeah. So I used to use Docker Compose a fair bit, which is quite nice, but that's just the purely the deployment part. So it allows you to, set up your cluster with multiple containers and do the networking and all that kind of stuff. But that's not enough, right? You want scaling and pod failover, and you want load balancing and all this kind of stuff. Which was Kubernetes gives you. The one annoying thing as a side note about Kubernetes is their rather frequent release cycle. But in my opinion, that's probably something to do with the product maturity as well.
Said Mr.
Yeah, it's just every
at Kubernetes, right?
Right?
Most people would consider that to be a dig at Kubernetes, no?
No. It's
every 6 months. Okay,
I thought
it was every quarter or something like this. No?
Yeah, it's very. You're right. It's. Take 122, right? That was released, say, a month ago. A month ago.
No, can't be, because that was 123.
Sorry,
the latest.
Okay, let's say the latest 122. So 122.8 was released in the 16th of March. Is end of life in October. That's
probably just a bug fix update, because I think the last version, and we're recording this in April, was, I think, 123, but maybe I'm completely off here.
Oh yeah, the latest one is 123. Yeah, which
released in March too, I think, if I'm completely mistaken.
Yes. So 1.3.1 was no 1.3.1 was end of 2021. So that's about a year. So the patch
That's probably something called or comparable to a long-term support release as an LTS.
It's like, about a year,
right? Like Jammy, our favorite LTS coming from Canonical, which has just been released a couple of days ago, actually.
Yeah.
So, Martin, if you want to update your LTS box, now's the time. No, actually, you have to wait if you're still running 2004. You have to wait until 22.1 drops, which is probably around August.
Okay, I can wait. That's fine.
But this is not this is not the Ubuntu podcast.
No.
No, it's actually Linux Inlaws, exactly.
Yeah.
Not today. So going back to Kubernetes, what are to these orchestration frameworks for containers? I mean, what are probably the most prominent challenges with running these millions of containers in production?
It's mainly having to deal with YAML, in my opinion.
Spot on, Mr. Vickers, spot on. No, it's not JSON. No, it's not scaling up and down. It's not fault tolerance. It's not high availability.
None of those. Exactly. Yeah. The most annoying part is YAML.
Well, Martin, you'll be glad to hear you can use JSON if you choose to do so. It doesn't have to be. Some
minor inconveniences of Kubernetes apart. There's obviously
for the two listeners who are not familiar with Kubernetes, what this joke was all about.
Okay.
Guys, there are kind of gals also, as in people. There are two approaches. If you if you're using Kubernetes, there are two approaches. You can tell either Kubernetes on the command line what to do, or you can, and this is the imperative mode. I always keep confusing them. And there's another, exactly, this is called the imperative mode, and there's another approach to configuring containers, as in telling Kubernetes what to do, and that's called the declarative mode, which uses manifest files. And these manifest files, as Martin
is that the M in YAML?
Exactly, are mostly written in YAML. And of course, these manifests basically tell Kubernetes how to start a container, where to get the image from, what to do once it has started a container, how many replicas there should be for a container, all the rest of it.
Mm-hmm.
And this is
before you move on to replicas.
Called YAML.
Yeah. Yes.
What does YAML stand for, Martin? Yet another markup language or something?
Sounds about right. Yeah. Yep, that sounds right. Anyway, before we move on to YAML, so yeah, if you running a container as a single object or runtime is fine, but when you are running in production, you may want to run this on multiple machines. So Kubernetes has the concept of worker nodes, where so-called pods can be deployed, giving you scalability and, in some cases, better availability of applications.
I couldn't have put it better, Martin. I mean, the whole idea of containers, especially in these orchestration frameworks, is essentially you're looking at a throwaway unit. Because if a container dies...
yes and no. But yeah, carry on. We'll come
sorry,
on to that.
Martin, you want to finish that sentence? By all means, just go ahead. So a container is born and then it dies. And what happens then, Martin?
Then
fair enough, yes.
Yeah, Kubernetes will start up another one somewhere else if it depending on its YAML configuration. But that was the original concept behind it, right? It's this throwaway. It's what's the term? It's cattle instead of pets, isn't it? Right? So it's you can have as many as you want to, and when you don't need them anymore, you just shoot them in the head, kind of scenario or something. That was the idea behind Kubernetes. But then people wanted to also run databases in there, which obviously doesn't work so well. Which
was a bad idea from the beginning.
It was kind of contrary to the concept of the whole thing.
But this is, of course, my personal opinion.
Yes. Yeah.
I know, jokes aside, I mean, the problem starts, of course, with, for example, if you have containers that want to talk to each other. So why don't we go through a very high-level description of Kubernetes to give the listeners some ideas of what we're looking at? The whole thing that Martin has just kind of already alluded to, well, containers live in pods. So a pod is essentially a collection of containers. The important thing to remember about a pod in Kubernetes is that a pod is only confined to a cluster node. You can have more than one node in a cluster. You probably need this.
But they're called workers in Kubernetes, aren't they?
Correct. Yes.
Which is it's not a physical machine. You could have multiple Kubernetes workers on a single machine as well, and so on. Anyway, yeah. It's an abstraction.
That can be whatever. Yeah, exactly. Yep. And of course, there's also a master, which is typically the first node that you set up in a Kubernetes cluster. And of course, the beauty is that you can roll your own. There's something called there are quick start things called Minikube, KubeADM, and some other approaches that give you basically a cluster out of the box with either a couple of VMs, or a single node cluster can be set up with something called Minikube pretty quickly, because it's all that Minikube does. On your machine, it installs a hypervisor if it's not already present, and then it downloads a couple of containers that make up a single node Kubernetes cluster, and that's all. Mm-hmm. So going back to these pods, the thing is, of course, if containers want to talk to each other, you have an issue, because if a container can disappear randomly, and that's exactly what these orchestration frameworks look after, among other things, these containers, or the other containers, the remaining ones, shouldn't be necessarily aware of this. So one of the first things that actually come to mind when you think Kubernetes is also a network abstraction layer that is typically known as a service in Kubernetes, because that adds network functionality on top of pods. That allows you to access pods in the cluster on different, maybe also on different nodes, but also, very importantly, these pods can be then accessed via services from the outside of the cluster. Especially important if you're running applications outside your Kubernetes deployment.
Well, hang on a minute. You're running applications outside your Kubernetes deployment?
Yes.
Wasn't the whole idea to put them all into Kubernetes?
Well, that depends. I mean, if you have this general ledger that has been running on a mainframe for the last...
We don't want to put that into Kubernetes.
Years, no. But for some reason, that general ledger has to talk to some fancy hipster marketing application framework for whatever reason that runs in the container. Yes, of course, you would need access to this container stack, to this container base stack rather, running in Kubernetes from the outside. Mm-hmm. And that's exactly where things like services come into play. Other abstractions regard storage, because as the listeners of the previous episode on operating system virtualization will recall, containers are ephemeral, meaning you start up a container, and unless you have taken explicit provisions, all the memory that a container contains is gone once you destroy the container.
Yeah.
That's the reason why typically modern container frameworks such as Docker allow you to, for example, to mount volumes from the outside. If you start a Docker container and then you tell it to mount a volume, the application or the processes running in that container then have access to the local file system of the supporting operating system, meaning that any data can be stored outside the container if this is stored on the mounted volume path. So Kubernetes has something called persistent volumes that exactly look after this persistent storage. And in that notion, or in that context, there is a so-called persistent volume claim, PVC, that actually tells Kubernetes, no, I need some storage on a device. Simplified.
So I have a question for you. Why is it called a claim? Why are we claiming storage?
Because claims can be denied.
Okay.
They shouldn't.
That's a bit kind of inconvenience if you need it.
Indeed. The reason why it's called a claim is essentially that you can parameterize the whole thing. In terms of you are not bound to a particular volume because a PVC refers to an existing, ideally, persistent volume. And then that persistent volume tells Kubernetes where to find the storage, what nodes to involve, and all the rest of it. This is the idea behind separating a claim from an actual persistent volume as such.
Yeah. There's another kind of main concept with Kubernetes. It's really every request is a state change request, isn't it? It's not a let's say similar to your volume claim. You're asking for Kubernetes to do a state change, and so it's all asynchronous, and will come back when it's changed that state, basically. So
yes, there's something very important. Exactly what Martin is referring to is a state change on the so-called control plane of Kubernetes. The control plane is essentially an API server that keeps the state of the cluster consistent at all times, or at least tries to. And that control plane is supported by two entities on the worker nodes called a kubelet and a kube proxy. The kubelet essentially controls all of the things going on a cluster node, like creating containers.
Sorry, did you explain what a kubelet is?
Yes, I was just about to.
Okay, sorry. Just checking.
So a kubelet basically. Imagine the creation of a so-called deployment. Essentially, a deployment tells Kubernetes what containers to use or what containers an application consists of, and how these containers should be scheduled. Hence, the notion of a deployment that corresponds to a replica set, to pods, and all the rest of it. Is essentially it's a combination of a couple of pods as in containers, as a network as in service, and some other things like replica sets that allow you to scale pods accordingly while they're running, by the way. So essentially, when Kubernetes is accepting deployment, what happens in the background is the control plane will accept this request, will then go out to the worker nodes, will create the containers that make up the pods, and then we'll create the services, the replica sets, and all the rest of it until it has reached a state that is defined in the deployment, and then it considers the deployment to be created. And for this, you need something called a kubelet running on each and every cluster node that, for example, takes care of the local creation of the containers by talking to the container runtime, whether it's CRI-O, whether it's Docker, whether it's Rancher. Because all of these container runtimes, as long as they're OCI compliant, are, the Open Container Initiative, that's the standardization body behind this interface, can conform to these OCI things. So essentially, the kubelet then knows how to spin up containers. The kubelet also knows how to talk to the local operating system running on the nodes in order to, for example, create services. Because under the hood, essentially what it does, it creates a local space in collaboration with the container runtime. And then, in the case of Linux-based containers, for example, it takes care of creating the network entities by, for example, using IP tables. So it creates a couple of virtual network layers on top of the existing operating system visible network. And then you have fabric controllers like Flannel and so forth, also adding another layer of abstraction on the existing network stuff in order to address namespaces. A namespace in Kubernetes is essentially a collection of abstractions like deployments, like persistent volumes, persistent volume claims, pods, services, you name it, and some other entities that are separated from other namespaces that allow you to rather easily segregate applications from one another. There are a couple of default namespaces in Kubernetes. When you set up a Kubernetes cluster, you have at least 2 default namespaces. One, funny enough, called default, yes, and the other one is called kube system. And this kube system namespace hosts all the infrastructures, funny enough, also running in containers, that Kubernetes needs internally to control cluster nodes, control the control plane, make the control plane work, and also take care of the API server and all the rest of it. So if you set up a Kubernetes cluster, if you simply take a look at kube system, this is your Kubernetes system running on the master node and all of the worker nodes. Mm-hmm. Funny enough, if Kubernetes doesn't start up properly, the first thing I normally do, I take a look at the entities in kube system to make sure that, for example, all of the containers that make up Kubernetes in their pods in kube system are up and running. Because, a little bit technical now, Kubernetes...
Are you running your own Kubernetes, by the way?
Just for fun. Sorry, Martin, because I can.
Just checking. You could just go to Amazon or Google and just run one of the Kubernetes distributions.
But A, that costs money, and B, I have the hardware already, so why buy a hyperscaler?
Okay, fair enough.
Full disclosure, people, Martin is the hands-off type of the two of us. I'm more the hands-on type. Martin likes to...
Think simple if I don't
exactly. Martin likes to talk about PowerPoint slides.
What is PowerPoint?
And
that doesn't sound very open source.
Sorry,
surely you mean open office.
Yes. So Martin likes to impress people with impress slides.
Impress.
We're getting somewhere, exactly. So Martin also likes to hand out PDFs to the people listening to him. These PDFs contain glossy, marketing-oriented content aimed at business people and other interests and other people having the mood
or to like you're describing your own job there, Chris.
No, my job is actually to make things happen, basically, that people like you promised. I'm the opposite. So you give an environment like a virtual machine, I make things happen. So hasn't really changed. No, jokes aside, people. Setting up a Kubernetes deployment, especially if you want to get going on that technology, is straightforward. I kind of already mentioned Minikube. Minikube, as I said, is a 5-minute job, and then you have your single node cluster, of Kubernetes up and running on your MacBook Pro, on your Linux machine, I think even on Windows, if I'm not completely mistaken. So what I did recently in order to staff my playground, if you will, in terms of populate my playground, just to have a couple of cluster nodes, I essentially, because I had nothing better to do, I took one of the laptops that actually was running, I think, Ubuntu or Debian, put 2 VMs on it, or actually 3 VMs with KVM, which comes natively with the kernel as a kernel virtual machine. There's a handy toolset called libvirt.
Is running on at the moment.
Yeah, there's a handy abstraction layer called libvirt that takes care of the command line interface into KVM and other hypervisors. Then basically I had a set of 3 VMs, and then I used simply kubeadm, and links will be in the show notes. Essentially the way you do it, you create using the first VM, you download the software to the first VM, you create the cluster, that makes that first VM the cluster master, and that basically gives you a single node Kubernetes cluster. As part of this kubeadm installation, you get something called a secret. You go to the remaining 2 nodes, or I went to the remaining 2 VMs and executed kubeadm there, simply giving that secret to the installer, and then pointing kubeadm at the existing first node, and within about 20 minutes, I had my 3-node Kubernetes cluster up and running on one of my laptops. It's not that difficult. And then I had a 3-node
So what are you
Kubernetes
running
cluster.
on this Kubernetes cluster?
Anything that's
Okay.
no, I mean, I just needed a playground for a couple of things. But rather than going to a hyperscaler like Google, like Azure, or like the bookshop and paying money for this, because I had the hardware sitting on a shelf doing nothing anyway, I simply did it on a laptop.
Okay, well, you heard it here first. You don't need fancy hardware to run Kubernetes on your laptop.
I mean, exactly. If a single node cluster is sufficient, just use Minikube. I mean, Minikube does it all for you. And getting this up and running, as I said, is a 5-minute job.
Okay. Any other container frameworks you'd like to discuss?
You mean orchestration frameworks? I mean, yeah. I mean, it's well, you already touched on Docker Swarm, but
should we touch on OpenShift actually?
Well, in that case, we might as well explain operators and Helm charts. Joking. No. What is OpenShift, Martin? I mean, you're the Red Hat fanboy, right? Of the two of us.
No.
You're not. I thought you were.
I don't know if Red Hat has any fanboys. Yeah.
I think
if you're a Red Hat fanboy, please write to us.
Yeah. Email address is feedback@inlaws.eu. Exactly. Red Hat. OpenShift. The idea behind OpenShift essentially is to package, and correct me, Martin, if I'm wrong, because I haven't used OpenShift in ages, to package a certain functionality on top of the native Kubernetes deployment and sell this as a shrink-wrap product. And that's exactly what Red Hat used to do anyway.
OpenShift is also an open source project, right? So yes, obviously there's the Red Hat version, but there's also the open source OpenShift project.
So what's the difference?
And yes, it uses Kubernetes underneath. Yeah.
Yes. I mean, what's the difference then beyond this fancy web UI that you get with OpenShift and the different command line interface, which is mostly compatible to native Kubernetes, if I'm completely mistaken?
Yeah, I think it's more a higher level of abstraction again, where you can define application templates and things like that, right? So if you remember in the Redis days,
Redis Labs, as it was then called.
Yes. For example, you could have single node Redis as a template, or a three pod Redis with HA, etc. as different templates, so that
yes.
rather than for as we previously mentioned, people having to write a bunch of YAML to decide what kind of Redis cluster they wanted, they just pick the template and click a button. So it's more slightly, let's say, more user friendly than a bare.
Which is not too far off from something called a Helm chart, if current law is anything to go, because exactly that's more or less what a Helm chart gives you. A Helm chart, like OpenShift, I would compare it to a distribution, let's put it this way, because a Helm chart is essentially a package manager for Kubernetes. You pointed to a repo. That repo has, well, yes, templates probably would come close. In Helm they're called Helm charts, but these Helm charts essentially tell Kubernetes how to instantiate, say, for example, a database instance, how many replicas this has, what the deployment looks like, how availability is configured, how the volumes are configured, and all the rest of it. That's exactly a Helm chart. In addition to this,
true.
Kubernetes, as far as I know, since version 16, 12, maybe I'm completely wrong, has the notion of an operator.
Indeed.
Where an operator, in comparison to a native Helm chart, has much more lifecycle functionality built into it. For example, comes in handy if you're a hyperscaler.
Before you move on to that, what is an operator?
An operator is essentially it's a package. It's a package and deployment description.
It's a bunch
or definition.
Of code, right?
Yeah, it's a bunch of code. Helm chart
written
is
in
more
which
like
language normally?
Martin, I've never written operator, so you tell me.
Oh.
Probably something fancy, like
It's usually Go.
YAML?
That's
Go,
the,
okay.
that's the
Go.
the native Kubernetes language, right? But,
And you've read this on one of the Impress slides?
No. We build many operators over here.
See.
Yeah.
Yeah, as a matter of fact, you can.
So if you want to
write,
go to the next level, write your own operator for your own application. Yeah.
Of course, you can write operators in any language as long as you adhere to a REST-based API, because that's exactly what Kubernetes implements. So as long as you have something that can talk REST, operators are not too far off, because essentially at the very bottom of the definition, operator is just an SDK that allows lifecycle aspects to be implemented.
Yeah, fair enough.
Martin, of course, disagrees.
It's fine. Yes, we can stick with SDK.
Martin, you're more than welcome to contribute any further technical details to the show notes.
Okay.
So that people can do their own app operator implementation.
Yes.
No jokes aside, Martin is of course right when he says it's a little bit more than just a Helm chart, because, for example, billing is baked right into the operator definition, which comes in handy if you're a hyperscaler, because at the end of the day, you want to bill your customers for any deployment that you run on your infrastructure. Needless to say, also, if you are a service organization within the company, you probably want to bill your lines of business for the services that you supply. And one of the ways to do this, if a line of business wants to deploy, say, an application that consists of a couple of ports and has network services running on top of that and all the rest of it. So they basically tell the DevOps people then to write an operator definition that basically takes care of implementing this service, and then also has billing baked into it, so that the operational organization essentially can charge for this deployment, being part of the lifecycle aspects of this operator SDK definition.
So you'll find many commercial pieces of software will have developed an operator to deal with, say, Postgres or Redis or RabbitMQ, whatever it is, right? It's the best way to lifecycle those kind of products on a Kubernetes cluster, indeed.
And needless to say, you can get pre-authored operators on places like GitHub, or in places like GitHub too. I mean, for example, I can record at least one Redis operator for Kubernetes being on GitHub. I think it's either from Amadeus or some other company, where they simply open source their operator deployment.
Yeah, you'll find many open source implementation for Postgres or for RabbitMQ. I don't know about Redis, but it's so typical things that an operator needs to do is all the standard things like provision databases and back them up and all those kind of things that
absolutely
come with these types of software. So operators are bespoke to the type of application that they are built for.
Anything else we should talk about?
Let's think. So
the road forward.
The road forward.
What's in store for container orchestration frameworks?
Well, that's a good question. Well, the only thing that I see is that everybody is busy, let's say, refining their operators. Kubernetes itself, they have cracked most of the problems around, the stateless, stateful sets and replica sets and things like that. Have you looked at the roadmap? I don't know what's on the roadmap, to be honest.
Well, not in a great level of technical detail. I was referring to the big picture, of course. I mean, it's probably a fair assumption to say that Kubernetes and friends, dissimilar to things like OpenStack, won't go away anytime soon. That's probably a fair assumption.
Sorry, did you mention OpenStack?
I did indeed.
What did you say about OpenStack? It's not going away anytime soon.
No, it is similar to OpenStack because
dissimilar. Okay.
Dissimilar, yes.
No.
Unlike.
I came across a customer the other day who was running OpenStack still.
Yes, you will find a few telcos here and there that sit on OpenStack, but in general, OpenStack has more often than not disappeared. As I said, isolated environments like telcos, sometimes financial service institutions do run OpenStack. But funny enough, when they talk about these internally, they more often use the term legacy than not, and there's a reason for this. So it's fair to say, Kubernetes is the way ahead. What you will see more and more is also the proliferation of Kubernetes to something called the edge. In terms of Kubernetes is making its way into embedded systems more and more.
Why? Because
containers are lightweight.
Yes, but okay, Martin,
of course, doesn't agree. No, I mean the idea is to extend the realm of, say, a deployment beyond the bricks and mortar walls of your local data center or a hyperscaler in general.
It's an interesting idea. I guess on your embedded device, you could run
it's happening. It's happening right now. People are moving away from heavy virtual machines in embedded computing to actually something called Kubernetes.
No, yes, okay. Running containers is fine, but actually running a whole Kubernetes cluster on an embedded device seems a bit overkill.
Well, a Raspberry Pi sets you back, I think, $40, €30, something like this.
Yeah, but so fine. You run Kubernetes on an embedded device, and then your embedded device fails. So how are you going to fail over, right? This doesn't really make any sense. So, it's a clustered deployment after all. Why would you run that on a single piece of embedded hardware?
No, you don't run it on a single piece. You run it on a couple of cluster nodes.
Okay.
Which is made up from embedded.
Devices.
Yes.
Okay.
Yes. Exactly. Yes.
Okay.
Sorry. Yes. It took some time, but yes, that's exactly what I meant.
Okay.
And you see this happening as we speak.
Okay.
If you take a look at any telco, especially mobile operators, the likes of Verizon in the US, the likes of
if we're talking embedded devices here, we're talking about some reasonable sized room in a cell tower, right? Not the Raspberry Pi.
No, we're talking about computers running on transceivers. We're talking about computers running as part of a fleet management deployment, that sort of thing.
Fair enough.
And more, you actually see Kubernetes-based container deployments in this embedded space. Because of scalability, 5G is helping a lot, of course, like powerful mobile networks.
Indeed. Another thing that I see in my day-to-day around Kubernetes is that people are running more and more separate Kubernetes grids rather than just one big one.
Cool.
So rather than kind of as a
which makes sense because at the end of the day, hybrid deployments, as in hybrid, of course, meaning that portions of your workload is running in a public cloud infrastructure or private virtual private cloud infrastructure, and the rest is probably running on premises for whatever reason. Compliance comes to mind and all the rest of it. In that case, Kubernetes, as multiple Kubernetes deployment come in handy because essentially you put your separate deployments into separate namespaces or even separate clusters, but because of the standardized approach that Kubernetes brings to the table, they can still talk to each other because we're looking at standard APIs that are highly interoperable. And of course, the things that Kubernetes natively brings to the table are scalability, high availability, and fail. What's what I'm looking for? Not failover, but
DR.
Augmented reality? No. No. High availability and fault tolerance. That was what I was looking for. So, any parting remarks before we go into the feedback and some other stuff?
I have some parting remarks. slightly on a marketing note, but it's also quite interesting because I
didn't know this.
Hey?
Didn't I know this?
No, but I didn't know these things either before I joined VMware. So they have something called a Kubernetes grid, which manages multiple Kubernetes clusters, as well as a native Kubernetes deployment in vSphere. So that makes the move for adoption by your system administrator slightly easier than having to install it all from scratch if they're not Chris Zimmerman who uses it on a laptop. But it's
are people still using vSphere? Okay.
Oh yes, yeah, many people.
I see.
I was surprised for sure.
Interesting. If you're out there, if you're using vSphere and if you're using vMotion if you consider yourself a VMware fanboy, please write to us. We would love to hear about you, especially Martin.
Yeah, not really. But
I see.
It is surprising how many people still. I mean, this is general related to the Kubernetes story, right? The number of people that are running this in large amounts in production are still in the minority, I would say. But yes, it will come. It will come.
Okay.
What about yourself? Any parting thoughts? Oh, we have feedback.
Yeah, sorry. Yes, I think I shed some light on my side of the story in terms of where I see Kubernetes is going. But
okay. I thought you did that already. Yes.
Yeah, exactly. So yes. Confusion abound. Anyway, it doesn't matter.
No, it doesn't.
Going forward, yes. Feedback. Yes. We have.
So I have one here that's specifically addressed to you from someone called the USB Trader. Thank you for requesting a quote. You have 4 unread messages from Yvonne. Read now, blah blah blah. Thanks, Chris. So this is.
I think you're confusing that with your spam mail.
No, it's addressed at feedback@linuxinlaws.eu.
Is it? Maybe my spam filtered this out already.
Okay, on to a more serious feedback note.
Indeed, Martin. Indeed.
Do you want to do the next one?
Yes, a guy called.
I don't know which one are you reading.
I'm referring to the one that we got.
45?
Sorry, a guy called Bitten, or Lady, posted on Hacker Public Radio on April the 11th. More Europe-centric. Here in Europe, we have EDRI. EDRI, exactly. And in Sweden and DRI, for example, that's
EFRI.
More European variants of EFF. And of course, she's referring to the Georgia Electronic Frontier episode, if I'm not completely mistaken.
Yeah.
And of course, you're absolutely right, Bitin, but that episode was geared towards a more US-based audience. No, jokes aside, absolutely. I mean, what we didn't mention in that episode, and of course, you're spot on, is that there are many, many, many similar organizations here in Europe as well and elsewhere. As you will find with other organizations centered on civil rights, civil liberties, freedom of speech. You see this actually also in the software world. The Free Software Foundation has a European counterpart called the European Free Software Foundation, funny enough. So, yes, the EFF is by no means, as in the Electronic Frontier Foundation, is by no means world exclusive.
Okay.
You want to read the next one?
Sure.
The one on non-profits?
Not the rest one. No, let's do the rest one last. Actually, that's not feedback anyway. Non-profits, yes. So this is on episode 52. Comment by Clacky,
yes.
Okay, he says, the nitty-gritty of US non-profits. So this was the Zig episodes.
Indeed, with Lois Crow, our friend.
Indeed. Crow says in the episode that a 501c6 cannot accept donations. It can, but unlike a 501c3, the donation to a 6 is not tax deductible as a charitable donation. More important difference is that a 501c3 is required by law to work for the public good, whereas a 501c6 is required to work for the good of its members. Then he has a follow-up one. More in-depth discussion about the differences between public charities, 501c3, and trade associations, 501c6, by Bradley Kuhn, who
Software
now
Freedom, exactly, Software Conservancy.
Software Freedom Conservancy.
Yes.
Link in show notes. Yes, so
yes.
it has been.
And Martin, that reminds me, this is now the 69th
It's what's
comment
right?
that we got. This is the 69th comment that we got on 501Cs and 6s and 3s and all that. So we should probably do an episode on US non-profits.
Okay, I might be otherwise engaged on that day. Feel free to carry on.
This is, of course, lame excuse. Clucky, if you're listening, if you want to come on the show, simply send a short mail to feedback@linuxinlaws.eu so that you can stand in for Martin if you can't make it on that day. No, just aside, Martin, what we should actually do is, and this is quite serious now, we should probably spend an episode actually on US nonprofits, because some of the stuff also applies to European organizations and the implications that these tax laws have on any serious nonprofits, especially in the world of software freedom, civil rights, and all the rest of it.
Yeah, no,
okay.
That's good.
And we also got a post on feedback on episode 45.
Indeed.
And that was which one? Bear with me. That, of course, is an ancient episode.
Is that the end of
Yes, that was the big Christmas New Year bash with the Grumpies. Our beloved friends, yes.
Yes, how are the Grumpies?
And the feet, yes, good question. Haven't heard from them in a while.
Okay.
Anyway, the comment reads like this: love this show. Reminds me a little bit of the UDEF Random podcast. This one had a lot of laughs. You guys are my friends for now. Thank you. Mine won't do anything.
For now, what?
For now.
Okay.
Yeah, but better for now than
friends
never.
for life,
right?
surely.
Okay.
No, okay.
And that is, of course, from our friend, the operator. Also, if I'm not completely mistaken, frequent contributor to Hacker Public Radio, as in a host.
Yes.
Holidays are hard, and now I'm quoting again, holidays are hard for most people. Shooting the shit and ranting are my fav podcast apps. Take care of yourselves. You are the only you have.
For all the people amongst us. Yeah.
Yes. Operator, thank you very much for your lovely feedback. We do appreciate that. And yes, keep them coming. Now, it's probably time for some boxes.
Yeah. Do we? No, we don't need to talk about the rest stuff. Good. Okay. Yeah.
No.
Poxes. Yes. Okay. Why don't you tell us what your pox is?
My pox would be a Hacker Public Radio episode.
Okay.
Did you have a chance to listen to this, Martin?
I don't know. Which one? What are we talking about now?
This is episode Hacker Public Radio episode 3577. Links, of course, will be in the show notes.
Okay.
A lady called Sarah explains how she got into computing, and this is the most hardcore thing I ever listened to.
It's what, sorry?
Sarah, it's the most. It was flagged as explicit for a reason.
Oh, okay.
People, if there's anything you want to listen to in terms of hardcore, yes, apart from another show marked as explicit, namely also known as the Linux Inlaws, this is the episode you should listen to. This is really hardcore. Sarah speaks about how she got into computing and some other rather gore or bloody things that I can't really talk about on the show. Links will be in the show notes. Sarah, if you're listening, I love this episode, and I'm sure that once Martin has had a chance to listen to it, he'll love it too. So if you want to come on the show, host an episode with us, you're more than welcome to. Please send a short email to feedback@linuxinlaws.eu. Martin, what's your box then? As a pick of the week.
Ah, yes. Yeah. Good question. Pick of the week.
You don't have any?
I do, but trying to remember the name of it now.
You mentioned Zelensky.
Yes.
Why would he? I mean, I get the idea behind the pox. Yes. I mean, if we're talking about the same Zelensky, who's currently trying to rescue the free world.
Yes.
I think the different one.
It's a well-deserved pox, yeah.
Fair enough. So you want to share some more thought on this, or should we leave it at that?
I think most people probably know enough about this. Yeah.
Links will be in the show notes. Yes, he's of course. If
or just watch the news instead. Yeah.
He's what? He's the president, or he's the prime minister, or all rolled into one?
Prime minister, isn't he? No. President, yes.
He runs a country called the Ukraine.
He does.
At the moment, I think.
Or what's left of it, yeah, indeed.
So, what's his first name? Is it Zabelgi or something like this? Can't even remember. So, Mr. Zelensky, if you're listening, full marks. Keep up the good work.
Yes.
And Martin and myself will put in extra overtime to pay more taxes so that you get the kit that you need. Rest assured.
And to any German listeners out there, stop taking showers. Yeah.
Martin has done this already.
No, we don't have to. We don't import the gas from Russia.
Did the wife move out? What about the kids? Are they still living with you?
Our gas doesn't come from Russia. Yeah.
Are you sure?
Yeah, it comes from Scotland.
Okay.
Or from the North Sea.
Fair enough.
Anyway.
So in that case, Martin, word of advice, do not annoy the Scots. Because if they cut you off, you won't be able to take showers.
Yes. Well, more importantly, we won't be able to get that whiskey anymore. So.
True. Very true, yes. And with that, as usual, would like to thank again Ken Fallon and the good people at Hacker Public Radio for hosting us. Thank you very much. And looking forward. And thanks for listening and looking forward to the next episodes.
This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
And we will have you on the show, in no time. Once again, cut, and we will send an email to linuxinlaws.eu, and we will have you in the show notes in the show in no time.
Show notes. We have to put them in the show first before we can put them in the show notes.
You have been listening to Hacker Public Radio at hackerpublicradio.org. Today's show was contributed by a HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hosting for HPR has been kindly provided by anhonesthost.com, the Internet Archive, and rsync.net. Unless otherwise stated, today's show is released under a Creative Commons Attribution 4.0 International License.